All right. Okay, so no making fun of how I look. I realize they look ridiculous, but I don't care that much. All right, so today we're going to focus on balancing, which is a new-ish idea. Hold on. So I have these examples, and I have some notes over on the right side to kind of help you. I would write them down. If you know how to balance, this will be a piece of cake. This is exactly the same as last year. For those of you that had chemistry before, you have one more chapter after this that you'll feel like, oh, this is easy. And then you're all going to be in the same sinking boat. So enjoy it while it lasts, because it's about to get a lot harder. So here we go. Balancing chemical reaction takes advantage of what law? Did we say it yesterday? The law of conservation of matter. Okay, which says the amount of matter you start with must equal the amount of matter that you end with. To ensure that in chemistry we have what we call balancing chemical reactions. So there are 10 reactions that we're going to balance here, and we're going to use them to teach you a few of these little rules that hopefully will make sense and hopefully will help this become something quicker. This is usually something way easier than naming and or formula writing. So we were kind of on the top of the peak. We're going to come back down before we go up a lot taller peak. So here we go. First off, you will notice that this Al2O3 going to Al plus O2 is not balanced, meaning I don't have the same amount of Als on one side and the other, and Os on one side and the other. So these right here, if you had me before, you remember they're called Tom Davidson's Time-Saving Tips to Save You Time. One of my favorite titles I ever made up of anything. They are not required. Like, you can certainly balance them your own way. These are only time-saving tips to save you time, not requirements. So I will use each one of these to illustrate one of these four. So what this means is when you go to start balancing, sometimes it's hard to know where to even start. Well, the answer to that is with the highest subscript that is not part of a polyatomic ion. Let's make sure we understand our vocabulary here. Subscript means the numbers down here. Okay? If you don't start with the one you have the most of, you may end up having to erase and coming back to fix something. So like here, if you started with aluminum, you would certainly have to come back and balance something. I have to wave to Mr. Reader real quick. He's not even looking up. Like, I could yell, but that'd be pointless. Like, my kids in my minivan, they'll like knock on the window and like yell at people next to us. I'm like, they can't hear you. Whatever. All right. So here we go. When we balance this, the highest subscript that is not part of a polyatomic ion is this 3. Now, there is not a polyatomic ion in this first example, so that doesn't really matter. But let's start by fixing the 3. So if you have 3 here and you have 2 here, we actually are going to use this trick also, which people mock me for this trick, but it saves them lots of time if they use it. It says, if you see a 3 and 2, you should use the swapperoo. What that stupid sentence means is in math, a 2 can only talk to a 3 if they both become a 6. So to make a 3 become a 6, you times it by 2, right? And a 2 to become a 6, you times it by 3. Did I say the same thing back to back? Whatever, you got me, right? All right, so here we go. In order to make this a 6, I take the 3, put it in front of the 2, and then this 2, put it in front of the 3. That's the 2-3 swap. It works every time if you have a 2-3, as long as there's not something in some other place to mess up the 2-3. All right, now, this 2 does what to the amount of aluminum? It doubles it. So if you have two twos, you now have 4. So to balance this out, you would have 2, 4, 3 as the coefficient. That might be a new term to us. The coefficient is the number in front. And in chemistry, we balance charges with subscripts, and we balance reactions with coefficients. That's super important that you get those right. It's a little confusing because pretty soon we're going to balance charges by doing names, and then we're going to balance reactions, and we're going to use subscripts for one, coefficients for the other. All right, 2, 4, 3, not the hardest thing you've ever done, right? If I was to put a teeter-totter here, it would now be balanced. Right? You have the same amount of matter on both sides of the fulcrum. Now don't worry about its position, just shut up. All right, now, next one here. Okay, let's notice first off that this does include a polyatomic ion. You all right with that? Just for practice. Magnesium plus, if it starts with an H, it has to be an acid, right? It's NO3, so it's called nitric acid. Goes to magnesium nitrate with hydrogen. All right, so here we go. First off, you would check to see if it is balanced, and you'll notice it is not balanced because there's a 2 on this NO3 and there is not one over here. There is a 2 on this H and there is not over there. Okay, so we start with the highest subscript that is not part of a polyatomic ion. So I am not going to start with this 3 because it is part of a polyatomic ion. And notice right here, leave polyatomic ions together if they are on both sides of the arrow. I should say the word balanced. I don't know if that makes sense or not. What I'm trying to say is since NO3 is one thing over here and NO3 is one thing over here, don't worry about balancing the N's or the O's. Just balance NO3 as its own individual thing, as long as it's on both sides of the arrow. So this is very simple. How many NO3s do you have? 2. You only have 1 over here. So how do you fix that? Put a 2 right there. All right, but that doubles the hydrogens, which is dandy because that's what I wanted it to do, right? So the rest are 1s. I would write the 1s right now because like a 1 will be an answer to your test. It wouldn't be a 0. You wouldn't leave a question blank, right? So 1, 2, 1, 1. Very not that hard so far. All right. One thing about balancing, it's always about consequences and repercussions. It's a line from a movie I really like. If you put a number to change something, it will have a consequence and you need to fix it. What's nice about that is if you know where to start, by fixing it, you'll create a problem to fix, and you just fix all the problems you make, and then all of a sudden you're done. It's a very logical process 99% of the time. All right, next up I have this one. K plus HOH goes to KOH plus H2. This one follows this general time-saving tip, and of all of them, this one might be the nicest because if you didn't do this often, you would make life a lot harder for yourself. This right here is actually water, which usually you would write as H2O, right? All right, this is the same thing, H2O. But if you have hydroxide on the other side, like it says right here, OH minus, write water as HOH, and treat water as it is 2 distinct parts, one H and one OH. If you will look at water that way, balancing is super easier if you're dealing with hydroxides. All right? So K plus HOH goes to KOH plus H2. All right, we discussed that. We're set. Now, the next thing, start with the highest subscript, not part of a polyatomic ion. Well, this is the only subscript So how do I fix that 2? Put in 2 in front of water, but aren't there 2 H's in water? No. There's 1 H and 1 OH. Treat them as 2 different parts and then life's easier. So if there's a 2 to fix that H, the consequence is it also affects the OH, right? How do you fix that? All right, you take this 2 and put it in front of the KOH. That fixes the OH but screws up the K. So what do you do with the K now? Put a 2 right here. You've fixed all of the things you broke, and now you're ready to go. What's that? Yeah, it is. It's my fault for breaking most of your 4 O's. Yeah. Look, I teach you well enough. You don't study well enough. Except for some of you. You're doing great. All right. Who's with me so far? Who likes this better than naming and formula writing? That's everybody. Did you raise your hand? No, never mind. It was almost everybody. All right, this red one is not crossed out because we're not going to do it. I want to do it in a minute. I would like you to try this one and this one on your own. All right, we'll take about 30 more seconds. All right, one of these should have been super easy, correct? The second one? All right, good. All right. So, this is our highest subscript. If there are 2 AGs, what do I put right here? 2. How come I don't put a 2 right there? Because that'd be dumb. Silver is not diatomic. We can't change subscripts to balance. That messes with the chemistry. We can change the amount of stuff. There's nothing against that. So 2 AGs. Did that cause any other problem? No. So 2, 1, 1, and you're done. All right, this one had polyatomic ions. I would balance them as one thing. Don't worry about balancing the P's and the O's. Like that could get way confusing because you have O in 4 different places. Focus on the PO4s and the OHs. All right, so the first thing to do is to find your highest subscript not part of a polyatomic ion. And there is an easier way to do this and a harder way. So there's 3 H's and there's 3 CA's, right? When given the choice, if O or H is your highest subscript, but there's something else, start with the something else. It will save you time. Now, you can start with the H, but starting with calcium actually is faster. So if I have 3 calciums, I'm going to put a 3 right here. That makes how many hydroxides? 6, right? So what do I need to put right here? A 6. That makes how many H's? 6. So I better put a what right here? A 2. That makes how many PO4s? 2. So I better put, whoa, I don't need to do anything. There's already a 2 right there. So 3, 2, 1, 6. If you start with hydrogen, it's okay. So if you take this 3, you would think that you would bring a 3 over here, but then you would see 3 OHs and 2 OHs, and then you have the 3, 2 problem, right? So then you got to go 3, and then you put a 2 or double this. There's your 6. That makes this a 2. That makes that a 1. So it's manageable both ways. But that little thing, once again, if if the highest subscript's a tie with something, choose something other than O and H. The metal is rare, so usually it will fix things right off. How many had that one right, by the way? Okay. All right. How about you do this one and that one as fast as you can? So there's the first one, if you want to check. And the second one's up, if you want to check. Who had a bolt right? Okay, that's a good sign. This one's kind of hard right here. Try this one. This is way above average difficulty. That's a 5. And if you did that, we'll go ahead and do the bottom one. We're going to do it eventually. So nice job. So the second to last one, calcium oxide plus diphosphorus pentoxide goes to calcium phosphate. 3, 1, 1. The reason why this one is difficult is because you have a polyatomic ion on one side, but not on the other. And then, to make it worse, you have oxygen in two different places. So if you look at this one, you have to do it separate. So you have 8 oxygens and you have 2 phosphorus. So you kind of just got to go from there. You have your 3 calciums, which is actually where I start, hands down every time, but that doesn't follow what I say specifically. To fix 8 oxygens and you have 2 phosphorus, you already have 2 phosphorus, so you don't want to change that. To make 8 oxygens, you just need 3 here, because then you have 3 plus, oops, that's supposed to point at the 5. 5 more, and that makes your 8. But like I said, and they didn't tie, the 8 was way higher, but a lot of times the coefficient on your metal will fix everything. Because if you know you have to have 3 CAs, just start with that 3, and then you're done. All right, you may or may not be done with this one. This one has polyatomic ions all over the place, but they at least stay together, so it really isn't that big a deal. All right, if you look, we have these 2 polyatomic ions in 4 different places. Your only subscript is right there or right there. This time it does not matter which one you start with. I'll just start with sodium. So I have 2 NAs. So I put 2 NAs. That makes how many NO3s? 2. So I better put a 2 right here. That makes how many H's? 2, which I already had. So I'm done. 1, 2, 2, 1. Who had that one right? Okay, good. Thank you. Say that again. Okay, pretty good. All right. Who feels okay about this so far? No? Hard? Okay. Let's make it worse. That's what I do for a living. Right? Like show you, like, it's not that bad. And then I just blow everything up. But honestly, this isn't that bad. Right? Former chemistry students? This one, like, some people like this one the most. This one always follows the same pattern. This type of reaction right here is called a combustion reaction. A combustion reaction is where something, most of the time, a hydrocarbon, which is a CH combination of anything, reacts with oxygen, and it always produces CO2 and H2O. So since the 3 of the 4 things are always the same, you can follow a very simple process to figure this out. And I'm going to put this on a different page here. So C6H6 plus O2 goes to CO2 plus H2O. All right, I'm going to do this, and then we'll write the steps down. If you already know it, you don't have to write anything down. But if you don't know, you should write this down, because these are sometimes the very hardest if you don't know what you're doing, but if you do, they're the very easiest. So the first thing I highly recommend that you do to save yourself time is always start just by putting a 2 in front of the first thing. Okay? Now you don't need to write notes, just kind of follow me here. So you start by doubling this hydrocarbon. The next thing we're going to do is fix the problems that just made. We take 2 times 6, and that makes what number? A 12. So the first thing you did, you started with a 2. The next thing you did is you balanced the carbons. Now look, it might seem a little bit weird, but we're going to just, like, don't think, just do. I'm going to take this number, and I'm just going to put it in front of water. I'm not going to use my brain. I'm just going to do what Davidson told me to. The reason why I say don't think is tons of people will put a 12 in front of water. Why would they do that? Because 2 times 6 is 12. But look, whatever you put here will already be doubled. Okay? So whatever numbers with H, just put it in front of water. Then, so these three things are extremely simple. You start with a 2, you put twice this number in front of this, and you put this number in front of that. The only thing that requires brain power is the following step. We now must find the number in front of oxygen. So just follow, it's not too hard. Oxygen's in 2 locations, so we have to account for both. 12 times 2 is what number? 24, plus, then there is 6 times 1, that is 6. So how many do I end up with? I have 30 oxygens on my right side. But I can't put a 30 right here because whatever goes here gets doubled, right? So I have to divide it in half, and I get a 15. So to balance this combustion reaction, it is 2, 15, 12, 6. And those numbers are way bigger than the numbers were on the other ones, right? They're pretty hard to figure out unless you just do those first 3 steps and then think through the last one. Okay, so if you're going to write down the steps, the first one, start with a 2. And that means double the thing at the start, double the hydrocarbon. The second thing is to balance your carbons. The next one is to balance hydrogen. Now, I said it in a little bit of a unique way. Balance hydrogen means just take the number with H and put it in front of water. Don't overthink it. The next thing, balance oxygen. And when you balance the oxygen, you have to always remember to divide your total oxygens in half because you have O2. Okay, are we ready for a few of these? Do you need this slide up still? Well, I can just erase this part. Let's go fatter. Okay, here we go. So when we have propane, propane is something you burn to cook food. C3H8 plus O2 goes to CO2 plus H2O. See if you can balance that. All right, you should be able to have been done by now. It's okay if you're slower, but start with a 2, balance carbons, take the number in front of H, put it in front of water, and then add your oxygens. This is 12 plus 8 more. That's 20 divided in half. You get a 10. Now, in this class, if they are all even, it is time that we should reduce. So 1, 5, 3, 4. So you might ask, well, then why did I double if I'm just going to reduce? And that is to save you time. All right? It will save you a lot of time just by starting with a 2. Now, on most of your tests, it won't matter if you leave that doubled, because math doesn't care if you have 2/10 or 1/5. But there are some chapters where we're going to use a value that is per 1 mole of this, and if you have 2, then your number is half of what it should be. Like, that'll make sense when we get there. All right, should we do another one? See how fast you can do these. Gasoline is called octane. Any guesses how many how many C's it has? It has 8. So its formula is C8H18 plus O2 goes to CO2 plus H2O. When I write these, if I'm doing it, do you know what I start with? I just write the 2 as I write it down. I wouldn't even, I would write 2C8H18 plus O2. Because what do you always start with? A 2. Okay, we have exactly 60 seconds. You got this. Don't panic, but you should have at least 2 perfect squares in your answer. If you do, then you are correct. 32 plus 18 is 50. My perfect square hint threw you off, I think. All right, so you start with a 2. That makes 18. Then you take this number with H, put it in front of water. 16, thank you. Sorry, 16. Randy's here. Now I'm super embarrassed. All right, it's okay because I knew this was going to add to 50. Divide 50 in half and you get 25. 2, 25, 16, 18. Who had that right? You're all amazing. Thank you. Do the homework some tonight from chapter 3 to practice. I will have these quizzes in probably after 4th hour.
I was just glad to get some simple stuff today.
You like that?